Question 1. Taking into account a newly constructed 8-story commercial office building in Phoenix, Mr. Alvarez is designing a ductwork system using the equal friction method. The system includes varying zones with different airflow requirements and long duct runs. One of the mechanical engineers suggests switching to the static regain method for better pressure balancing. Mr. Alvarez is concerned about complexity and cost. What is the most appropriate action Mr. Alvarez should take given the building's characteristics? A. Continue with the equal friction method as it offers simpler design, minimizing design time and cost. B. Switch to the static regain method to ensure uniform pressure distribution and efficiency in long duct runs. C. Use the velocity reduction method to decrease air velocity as it reaches terminal units. D. Combine both methods. Static regain for primary ducts and equal friction for branches. Answer. Correct answer. B. Explanation. The static regain method is ideal for large systems with long duct runs, helping maintain equal pressure outlets by compensating for velocity pressure losses, while more complex than equal friction ensures better air distribution. ASHRAE fundamentals and Manual D support static regain for high-performance systems. Equal friction may cause uneven air delivery in multi-zone setups. Question 2. From a practical standpoint, understanding heat transfer is essential in designing an energy-efficient HVAC system for a hospital surgery wing. Mr. Singh is tasked with designing the walls and ducts to prevent heat gain from adjacent hot mechanical spaces. He is selecting insulation material to minimize heat transfer into cooled supply air ducts. Which type of heat transfer should Mr. Singh prioritize controlling, and what strategy best mitigates it? A. Radiation. Applying reflective coatings inside the ducts. B. Conduction, using low thermal conductivity insulation. C. Convection, increasing duct velocity to reduce exposure time. D. Latent heat, installing dehumidifiers in the ductwork. Answer. Correct answer. B. Explanation. Conduction is the dominant heat transfer mode through duct surfaces from hot surrounding areas, using insulation with low thermal conductivity. G. Fiberglass or mineral wool minimizes heat gain. ASHRAE 90.1 mandates insulation standards for energy efficiency. Convection is internal air side, and radiation plays a minor role in duct-to-space heat transfer. Question 3. As demonstrated by a large mixed-use facility with retail, office, and residential components, Carter is evaluating HVAC options. Key challenges include diverse load profiles, independent tenant control, and high energy efficiency goals. She's considering chilled water system (ERF) systems and rooftop package units. Which system provides the best combination of zoning flexibility, energy efficiency, and scalability in this case? A. Rooftop package units due to their low first cost and ease of maintenance. B. ERF systems for superior zoning, simultaneous heating, cooling, and energy savings. C. Chilled water systems for their centralization and thermal storage potential. D. Split EX systems for simplicity and ease of control. Answer. Correct answer. B. Explanation. ERF systems are ideal for mixed-use buildings due to high zoning flexibility, simultaneous heating cooling with heat recovery, and part load efficiency. ASHRAE 90.1 and LEED for ERF for energy efficiency. While chilled water systems are scalable, they lack individual control and are complex to maintain. Question 4. What factors contribute to effective HVAC system control in a museum storing sensitive historical artifacts? Is Dubois selecting a system to maintain strict temperature and humidity ranges? She must avoid RH fluctuation to prevent artifact damage. Which combination of conditions should she most precisely control? A. Dry bulb temperature and dew point. B. Wet bulb temperature and air velocity. C. Relative humidity and dry bulb temperature. D. Enthalpy and static pressure. Answer. Correct answer. C. Explanation. Museums require tight control of both relative humidity, typically 4.555%, and temperature 6.872. Psychrometric control is essential to prevent material degradation. ASHRAE Handbook. HVAC applications and Standard 55 recommend closer temperature management in such environments. Dew point is important but less practical to control directly. Question 5. Under the assumption that Ista Ortega is sizing a chiller for a university campus with seasonal occupancy swings, he considers using one large chiller to meet peak load. However, a colleague advises staging smaller chillers. What is the most efficient and practical strategy? A. Install one oversized chiller for simplicity and future growth. B. Size a chiller for the average load and rent portable chillers for peak loads. C. Use modular chillers staged for part load efficiency and redundancy. D. Install the chiller outdoors to reduce equipment room footprint. Answer. Correct answer. C. Explanation. Staging modular chillers improves energy efficiency under part load conditions, offers redundancy, and aligns with fluctuating campus loads. ASHRAE 90.1 and 189.1 support modular solutions for improved part load performance. Oversizing leads to short cycling and inefficiency. Renting chillers is not cost-effective long-term. Question 6. When considering a building with extensive glazing facing west, Mr. Evans is performing a cooling load calculation. He must account for solar gains, internal heat loads, and ventilation. The design team insists on reducing equipment sizing due to budget constraints. What approach should Mr. Evans take to balance accuracy and cost efficiency? A. Base calculations only on average historical weather data to reduce over-design. B. Apply diversity factors and zoning strategies to right-size equipment. C. Ignore solar gain during the shoulder seasons to simplify calculations. D. Reduce ventilation rates to lower calculated load. Answer. Correct answer. B. Explanation. Using diversity factors and zoning allows accurate sizing while preventing over-design. Ignoring key variables like solar gain or reducing required ventilation violates ASHRAE 62.1 and 183 guidelines. Zoning high-load areas separately ensures system efficiency and comfort. Question 7. In light of recent developments, is Tanaka selecting refrigerants for a large data center cooling application? Environmental compliance, thermodynamic efficiency, and safety are all key considerations. Which refrigerant characteristic should receive the highest priority in this context? A. High attribute ensure system reliability. B. Low critical temperature to maximize capacity. C. Low flammability and toxicity, meeting ASHRAE 34 class. D. High discharge temperature for fast cycling. Answer. Correct answer. C. Explanation. Data centers demand reliable, safe, and environmentally friendly refrigerants. An ASHRAE Standard 34 classifies refrigerants by flammability and toxicity. Class non-toxic, non-flammable is preferred. Debut is required by the SNAP and Kigali Amendment. Safety and environmental impact outweigh capacity. Question 8. While examining a university's chilled water system retrofit, Mr. Kim proposes integrating modern BAS. The existing system uses manual valves and no central control. The facilities manager is concerned about cost and complexity, weighs the most compelling reason to implement BAS in this scenario. A. Reduces piping requirements due to better control. B. Automatically balances refrigerant charge levels. C. Improves operational efficiency and allows energy monitoring. D. Eliminates need for on-site technicians entirely. Answer. Correct answer. C. Explanation. BAS provides control, monitoring, and energy optimization through real-time feedback and trend logging. It allows demand-based control of chillers and valves, significantly reducing operating costs. ASHRAE 135 BACnet supports BAS integration. It does not reduce piping or eliminate human oversight entirely. Question 9. From multiple perspectives, understanding friction losses in a hydronic system is key. Martinez is designing a closed-loop system with multiple terminal units. She must ensure that the pump she selects can overcome both static and dynamic pressure losses. Which calculation is essential to determine correct pump head? A. Velocity head based on average pipe diameter. B. Total dynamic head including elevation and friction loss. C. Static head only since it's closed loop. D. Bernoulli's equation assuming no losses. Answer. Correct answer. B. Explanation. Total dynamic head (TH) accounts for friction losses in piping, fittings, and equipment as well as static pressure differential. Even in closed loops, equipment elevation matters. Neglecting DH causes pump undersizing. Ashry and Asper recommend friction loss calculations via Darcy-Weisbot or Hazen-Williams methods. Question 10. Contrary to popular belief, oversizing HVAC equipment does not improve performance. Mr. Delgado replaced a 15-ton rooftop unit with a 20-ton unit at a retail store expecting better cooling. Post-installation, occupants complain of humidity issues and short cycles. What is the most likely cause of this problem? A. The system lacks enough refrigerant to operate at full capacity. B. Oversized equipment causes short cycling and poor latent heat removal. C. Undersized ductwork is restricting airflow. D. The thermostat is not calibrated for a larger unit. Answer. Correct answer. B. Explanation. Oversized systems cool the space too quickly without running long enough to dehumidify, leading to comfort issues. Short cycling also wears out compressors. At ASHRAE 90.1 and 183 emphasize correct sizing for energy and humidity control. Humidity control is a latent load function requiring longer runtime. Question 11. To illustrate this point, Mr. Nguyen is designing a chilled water piping network for a multi-zone university lab building. Each zone has unique demand profiles and varying pipe lengths. The client requests that system balancing be minimized post-installation. Which design approach will best support balanced flow from the outset? A. Use reverse return piping to naturally balance system pressure. B. Install manual balancing valves at each terminal unit. C. Size all branch lines equally to eliminate pressure differences. D. Implement variable speed pumps without flow controls. Answer. Correct answer. A. Explanation. Reverse return piping ensures each branch sees similar pressure losses, promoting self-balancing. ASHRAE HVAC Systems and Equipment Handbook supports this strategy for systems requiring minimal adjustment. Manual valves require tedious post-install balancing. Equal pipe sizing may not account for load variability. Question 12. Through the lens of a mechanical equipment room retrofit, Mr. Beck observes exposed belt drives, low clearance walkways, and limited access to emergency shutoffs. He's tasked with redesigning the space in compliance with safety codes. Which aspect must be addressed immediately to meet OSHA HVAC workspace safety standards? A. Use only beltless direct drive fans. B. Maintain minimum 30 inches of clearance in front of electrical panels. C. Install variable frequency drives for soft start. D. Limit equipment noise levels to below 55 dB. Answer. Correct answer. B. Explanation. OSHA 29 CFR 1910.303 G1 mandates a minimum of 30 inches clear working space in front of electrical equipment for safety and access. While noise and belt guards matter, immediate code compliance hinges on safe egress and access. NFPA 70 also reinforces clearance minimums. Question 13. In what ways can a designer maximize thermal efficiency in a water-cooled chiller plant during part load operation? Mr. Cohn is evaluating operating costs and seasonal performance. What operational strategy improves system thermodynamic efficiency under variable loads? A. Run all chillers continuously at low load. B. Stage chillers so that only one operates near full load. C. Increase condenser water temperature during low demand. D. Disable economizer modes to reduce complexity. Answer. Correct answer. B. Explanation. Staging one chiller to operate near full load improves efficiency as most chillers perform better at high load percentages. ASHRAE Guideline 22 recommends optimized chiller staging to minimize energy per ton out. Running all chillers at low load increases in efficiency. Economizers are beneficial, not detrimental. Question 14. A detailed analysis of a newly installed valve system at a government building reveals inconsistent zone temperatures even though the system passed factory testing. Mr. Jarrett is leading the functional performance testing. Which steps should be prioritized during commissioning to resolve these discrepancies? A. Check the architectural specifications for damper placement. B. Calibrate valve box actuators and confirm control sequences. C. Rebalance the chilled water loop for peak demand. D. Replace thermostats with Wi-Fi compatible models. Answer. Correct answer. B. Explanation. Commissioning validates system operation under real conditions. VAV boxes must be calibrated and sequences verified to ensure proper modulation. ASHRAE Guideline 0 emphasizes functional performance testing of control systems, while thermostats and water loop balancing may not solve airside zone issues. Question 15. In comparison with conventional HVAC systems, HRConquer is evaluating the use of geothermal heat pumps for a library project seeking LEED certification. The team is focused on long-term sustainability and minimal environmental impact. What is the main advantage of geothermal systems in sustainable HVAC design? A. Lower air velocities increase occupant comfort. B. Constant ground temperatures improve heat exchange efficiency. C. SI economizers eliminate compressor use. D. Shorter duct runs reduce installation cost. Answer. Correct answer. B. Explanation. Geothermal systems leverage stable underground temperatures for high-efficiency heat transfer. This leads to reduced energy use and aligns with ASHRAE 189.1 and LEED's energy credits. SI economizers apply to air-cooled systems, not geothermal loops. Comfort and duct layout are secondary advantages. Question 16. By evaluating mechanical drawings for a medical research facility, Mr. Rogers notices discrepancies between the architectural and HVAC plans, particularly in ceiling elevations and diffuser locations. What is the best course of action before proceeding with duct fabrication? A. Adjust diffuser sizes to match available ceiling space. B. Coordinate with the architect to resolve plan conflicts. C. Continue fabrication based on the mechanical plan only. D. Move diffusers slightly during installation as needed. Answer. Correct answer. B. Explanation. Coordination between disciplines is essential to avoid field conflicts. ASHRAE guidelines and project specifications emphasize interdisciplinary collaboration before installation. Fabrication without resolving discrepancies risks costly rework and code violations related to ceiling clearances or fire rating breaches. Question 17. During the process of integrating an HVAC system into a smart building platform, Mr. encounters interoperability issues between the legacy BAS and new lighting control systems. Which protocol is most appropriate to ensure open communication between systems from different manufacturers? A. Lonworks. B. Modbus REU. C. BACnet. D. DDC loop. Answer. Correct answer. C. Explanation. BACnet ASHRAE Standard 135 is the most widely adopted open protocol for integrating HVAC, lighting, and security systems. It allows multi-vendor interoperability across building systems. Modbus and Lonworks are more limited in HVAC-specific applications. DDC loops are internal to one system. Question 18. The impact of selecting an air-cooled chiller over a water-cooled chiller is a central question in a renovation project for a small hotel in a dry climate. Mr. Delaney is analyzing initial cost versus lifecycle savings. Which financial concept should he use to justify long-term energy-efficient investments to the client? A. Payback period. B. Net present value NPV. C. Simple cost-efficiency ratio. D. Equipment depreciation rate. Answer. Correct answer. B. Explanation. NEV accounts for all future cash flows, savings, and costs discounted to present value, making it ideal for evaluating life cycle decisions. ASHRAE's cost analysis of HVAC systems recommends NPV of a simple payback. Payback ignores long-term savings in system lifespan. Question 19. Given the circumstances, is Novik investigates a complaint where a newly installed AHU is not maintaining setpoint temperature. The system includes a DE controller and variable speed fan. Initial inspection shows proper airflow and damper positions. What should she check next to diagnose the issue? A. Control loop tuning parameters for PID performance. B. Static pressure sensor location inside the duct. C. Filter replacement frequency logged in BAS. D. Fan belt tension on the supply fan. Answer. Correct answer. A. Explanation. If airflow is normal and mechanical systems are functional, PID control tuning may be the issue. Poorly tuned loops can result in overshooting, hunting, or sluggish response. ASHRAE Guideline 36 emphasizes proper loop setup for control system performance. Physical inspections alone may not reveal control issues. Question 20. In the modern context of fire safety in high-rise residential towers, Istabosu is designing a make-up air system for stairwells and fire-rated corridors. The system must comply with pressurization and fire containment standards. Which NFPA code most directly governs stairwell pressurization systems? A. NFPA 9-tier standard for air conditioning and ventilating systems. B. NFPA 13 installation of sprinkler systems. C. NFPA 92 smoke control systems. D. NFPA 70 National Electrical Code. Answer. Correct answer. C. Explanation. NFPA 92 governs smoke control systems including stairwell pressurization, ensuring egress paths are tenable during fires. It outlines design, testing, and maintenance requirements. NFPA 90 pertains to ductwork fire safety, but not active smoke control. NFPA 13 and 70 cover sprinklers and electrical safety respectively. Question 21. Given the challenge of designing an HVAC, a museum histories must maintain or reach 50% plus 3% year-round despite large seasonal changes in outdoor air conditions. Which strategy best maintains stable humidity while minimizing energy waste? A. Reheat coil after dehumidification cooling coil. B. Use bypass dampers to divert air around cooling coil. C. Increase supply air temperature set point during humid months. D. Add direct evaporative cooling in series with chilled water coil. Answer. Correct answer A. Explanation. Reheat after dehumidification allows cooling air below dew point to remove moisture, then reheating to desired temperature. This is common in museums per ASHRAE 2019 application CH 23. Bypass and evaporative cooling don't control RH precisely. Raising SAT in humid months risks moisture gain. Question 22. In contrast with round ductwork, Patel is designing a rectangular duct system in a retrofit where ceiling space is limited. The goal is to maintain equal friction rates and minimize fan energy use. Which adjustment is most effective? A. Increase aspect ratio beyond 4. 1 to fit tight spaces. B. Keep aspect ratio near 1. 1 and adjust width height proportionally. C. Reduce duct length without resizing cross-section. D. Switch to flexible duct for all main trunk runs. Answer. Correct answer. B. Explanation. Lower aspect ratios reduce surface area per volume, minimizing friction loss per ASHRAE fundamentals. High aspect ratios increase pressure drop. Space constraints require balance between duct size and efficiency. Flexible duct has higher friction and is unsuitable for mains. Question 23. Taking into account upcoming regulatory changes, Istahan is selecting refrigerants for a new ERF system to be installed in 2026 in the United States. Which refrigerant choice best aligns with current EPA AIM Act phase-down schedules while maintaining ERF compatibility? A. R400 TINA. B. R32. C. R134. D. R290. Answer. Correct answer. B. Explanation. R32 is lower distribute than R400 TINA remains compatible with many RF designs and meets AIM Act phase-down targets. R400 TINA is being phased down, R134 is mainly for chillers, and R290 propane is flammable and not widely approved for ERF in large buildings. Question 24. From the perspective of energy conservation, Lopez is designing a secondary chilled water loop with variable flow to match partial load conditions. Which device is essential for maintaining minimum flow through the chiller evaporator during low load? A. Differential pressure sensor at the farthest coil. B. Decoupler pipe between primary and secondary loops. C. Three-way valve at each terminal unit. D. Balancing valve on the pump discharge. Answer. Correct answer. B. Explanation. A decoupler bypass between loops ensures primary flow is maintained to protect the chiller while allowing secondary flow variation. ASHRAE HVAC systems and equipment CH12 recommends this in variable primary secondary systems. DP sensors aid control but don't ensure minimum evaporator flow. Question 25. Taking into consideration local code adoption, ISTA-SING is designing ventilation for a high occupancy classroom space. The jurisdiction follows ASHRAE 62.1. What is the primary basis for determining the required outdoor air intake rate? A. Outdoor air quality index. B. Floor area and number of occupants. C. Number of air changes per hour. D. Supply fan maximum capacity. Answer. Correct answer. B. Explanation. ASHRAE 62.1 specifies outdoor air intake using both occupant density cm person and floor area CFT. Outdoor key effects filtration, not O rate, which is used in healthcare codes ASHRAE 170. Fan capacity doesn't set minimum code required ventilation. Question 26. With the advent of stricter energy codes, HRConquer is tasked with retrofitting an office AHU to reclaim exhaust air energy without cross-contaminating supply air. Which technology best meets this requirement? A. Fixed plate heat exchanger. B. Heat pipe. C. Runaround coil loop. D. Rotary energy recovery wheel. Answer. Correct answer. C. Explanation. A runaround coil loop transfers heat between exhaust and supply streams without air mixing, making it ideal for contamination-sensitive applications. Fixed plates risk leakage, rotary wheels can transfer particulates, and heat pipes require proximity of airstreams. ASHRAE 90.1 supports recovery use for compliance. Question 27. Throughout the course of sizing a rooftop unit for a restaurant, ISTA Dyers notes high internal heat gains from cooking equipment, lighting, and people, which approach most accurately determines cooling load. A. Apply a standard occupant load factor only. B. UEM method considering envelope and internal gains. C. Base calculation solely on equipment manufacturer's capacity tables. D. Assume 10% safety factor over rough estimate. Answer. Correct answer. B. Explanation. EAM method considers conduction through waterproof and internal latent and sensible loads per ASHRAE Fundamentals EH. 18. Kitchens require accurate latent load assessment. Oversizing without precise load calculation wastes energy and reduces humidity control. Question 20. Under the assumption that an office building BAS must maintain comfort while reducing peak demand charges, ISTA-SING proposes a control sequence. Which strategy best addresses both goals? A. Demand-controlled ventilation with COS sensors. B. Night purge ventilation in summer. C. Chilled water reset based on an outdoor temperature. D. Staggered start of large HVAC equipment. Answer. Correct answer. D. Explanation. Staggering equipment startup prevents coincident demand spikes that cause high peak charge. DCV improves energy but doesn't target demand peaks directly. Night purge helps with free cooling, and chilled water reset reduces pumping chiller energy but not startup demand surges. Question 29. As demonstrated by a supermarket's medium temp display cases, ISTA Thompson observes frost buildup on evaporator coils and higher than normal suction pressures. Which is the most likely cause? A. Undersized expansion valve. B. Defective defrost timer. C. Overcharged refrigerant. D. Airflow restriction at condenser. Answer. Correct answer. B. Explanation. A failed defrost timer prevents scheduled melt cycles, causing frost accumulation and poor heat transfer. Suction pressure may rise due to reduced temperature differential. Overcharge raises head pressure, undersized TSV lowers suction, and condenser restriction affects discharge, not coil frost. Question 30. The fundamental question is how to select between air-cooled and water-cooled chillers for a coastal high-rise office tower. Which factor most strongly favors water-cooled? A. Limited mechanical room space. B. High year-round ambient temperatures. C. Unavailability of cooling tower makeup water. D. Desire for low first cost. Answer. Correct answer. B. Explanation. Water-cooled chillers maintain higher efficiency in hot climates because cooling towers reject heat more effectively than air-cooled condensers. Lack of tower water rules out water-cooled. Limited space may favor air-cooled. Low first cost is generally with air-cooled systems.